Okay, so you've had a little bit of time to work on this now. Let's see how you did. So we were going to figure out dy dx by separating it into dy du multiplied by du dx. So let's write down here the derivative of y with respect to u, dy du. The first part would be 2 minus 3u squared. Correct? That would be the derivative. And then the derivative of u with respect to x, the second part here, would be, first of all, what I would need to do, so not getting the derivative yet, right? But as always, if you have a fraction, you need to move that denominator up into a numerator position. So that would be, just for example here, I don't want it to be part of this one, and it's not technically the derivative yet, but I have that 1, which you'll see I won't write down at the end, and then I bring that x up, which would then be, it was an exponent of 1 to the exponent of -1. So really I would just make that, x to the power of -1, right? So then the derivative of that would be, bring the -1 in front, x, and then if I'm subtracting another 1, that would be to the -2, right? Which again, I probably don't want to write down the coefficient of 1 in front, so you would just end up with -x to the -2. So how'd you do with those ones? This one might have been okay, but how did you do with this one? So now to get the derivative, again, this was already written out before in the last video, but dy dx is going to be dy du multiplied by du over dx using Leibniz's notation. So let's just write down what we have. The derivative of y with respect to u is in brackets 2 minus 3u squared. And I'm going to multiply that, so I might as well have another bracket there, right? By du dx, which is negative x to the exponent of -2. Now, in order to evaluate eventually at x equals -2, right, I need to have all of this in terms of x's, not u's. So the first thing I need to do is change this u to, I know that the value of u is 1 over x, so change it so that all of my answer is in terms of x's. So now I'm going to have 2, so let's just write that down over here, just off to the side, y equals 1 over x from here. So 2 minus 3, and instead of u, I'm going to have 1 over x. Now that is squared. And then I don't need anything here. It's already in terms of x's, right? So now just in terms of multiplying, do I see any way to clean this up here at all? I could square this, but if I'm going to be plugging in the value of -2, I might as well do that first before I square it. But you normally don't want a negative exponent, right? So if we write this out again as 2 minus 3, 1 over x squared, and I just use different brackets just because I have another rounded brackets within the square brackets. And I'm going to multiply that by, again, that negative, the -1 would stay on top. And I would bring that x to the power of -2 to become x squared in my denominator, right? When I flip it, the negative becomes positive. So now I'm going to evaluate for x equals -2. So just whenever I see an x, I put a -2 in its place. So I'll just kind of highlight that with the red. So I have 2 minus 3, 1 over, just bear with me when I'm switching, it's going to take a little bit longer. Now, again, the whole thing is squared, right? The squared is outside. So the 1 is squared and the -2 is squared, multiplied by -1 over x within the bracket, -2, and that is squared. And then we're just cleaning this up. So then I would have here 2 minus 3. 1 squared would be 1. -2 times -2 would be 4. I still have to take that 1/4 and multiply it by 3, multiplied by, again, -1. It's only the -2 that's squared, which is, again, going to be a 4. So then, just to have, not to have to move this, I'm just going to go over here. Sorry. So just continue on along down the page, right? So then here I would have, let's say 2 minus, this would be 3 over 1. So 2 minus 3/4 multiplied by -1/4. So in order to multiply, right, BEDMAS brackets first, I have to subtract these fractions. So I need to get a common denominator. So this would be end up being a 4. So it would, for 1 times 4, multiply the top times 4, I would get 8. So 8 take away 3 would be 5. So I would have 5 over 4 multiplied by the -1/4. Then I can just multiply across the top, right, and across the bottom. So I have -5 over 4 times 4 is 16. So I've differentiated, I've gotten the derivative of the original functions, dy dx, and I also evaluated the derivative at x equals -2 would equal -5/16.